Welcome back to Math Mini Lessons. In Lesson 54, we're going to look at 1- and 2-step word problems. So here are the 3 things you can do to demonstrate you know how to do today's skill. 1, that you can identify and assign the unknown quantity in the word problem. So we're going to look for evidence of that. 2, that you're annotating and modeling using space, solve, and raise. And 3, that you can write an algebraic expression to represent the scenario with precision and making sure that you're also ordering the terms correctly. Okay, let's look at this problem over here. It's multiple choice, so we're going to start by reading together. Which situation can be described by the expression c plus 2.5? This is absolutely an EE problem. And our key information is we have some unknown c, and it's going to be increased by 2.5. So our strategy for today is going to be to translate each one into an expression. That's going to be our goal. And when we do that, remember we're trying to identify the term or the terms, the operations between the terms, and order. That's what we're going to look for and see if we can do some elimination work. All right, so all these are about Leah jogging. And my numerical guess is going to be the amount she's jogging. So she jogged in the first one c miles, that's our first term, and 2.5 miles further. So that further is telling me that it's in addition to. So whatever she jogged yesterday, c miles, she jogged 2.5 miles more today. So I'm going to use addition for that. So far so good. That's looking exactly like the terms we're looking for. Let's keep reading because we know that many students make errors when they don't go through all of them. They find what they want and they just keep going. So look at B and let's see if we have a reason for eliminating B, C, and D. Leah jogged c miles yesterday and 2.5 miles fewer today. So same terms, c and 2.5, but it's fewer miles. So that is subtraction. That is not what we're looking for. We can eliminate that. And there's my reasoning. Fewer means we're subtracting one term from the other. All right, Leah jogged 2.5 miles yesterday and c miles fewer today. So automatically just with the fewer, I know that that's going to be a reason this doesn't match. The terms are right, 2.5, but it's fewer miles. So she did some number fewer today. So the order is off and the operation is off. And the last one, Leah jogged 2.5 miles yesterday and 2 times further today. So 2.5 miles and c times. So I could either write it like this, 2.5 c. I could see some kids writing it like this in parentheses. I could even see some kids writing it like this. Either way, they're all multiplication and they're all wrong because we're not even looking for that. We're looking for those 2 terms being added together. So A is our correct answer. We have a great reasoning justification for eliminating the other 3. So awesome job. Let's hit pause so you can jot this down in your notes. Let's jump into problem 2, and I'm going to use solve for this one. On their family vacation, a number of children collect rocks. Maria collects R rocks, Javier twice as many rocks as Maria, and Pablo collects 5 less than Javier. Write an expression to represent the rocks Javier collected. Write an expression to represent the rocks Pablo collected. So pretty much we just need to write 2 expressions to represent what Javier and Pablo collected. And here are our facts. We have Maria's expression, which is just 5R. We know Javier had twice as many as Maria, and we know Pablo had 5 less rocks than Javier. So here's our plan, and it's going to seem a little complicated, but watch it in action with these steps. I'm going to start Maria's expression, and I'm going to translate an expression for Javier that connects to Maria's. So I want us to think, how does the number of rocks she has connect to what Javier has? Then I'm going to substitute R for Maria in Javier's expression. So I want you to think about what that looks like in the work. Then I'm going to write an expression that connects Javier and Pablo's number of rocks, and I'll do the same substitution for Javier's in Pablo's expression. So this might seem a little weird. It's hard to visualize right now, but hit pause, jot this down in your notes, and watch what this looks like as I'm modeling. Okay, let's put our plan into action using these organized facts. We're going to translate them into expressions and watch how we use the substitution to make it consistent throughout the entire problem. So we're going to start with Maria's. Maria is equal to R rocks. So we're going to have Maria be represented as just the one term R. So that's it, one term. That's what we want to do. We want to take that whole expression and just translate it to terms. Javier has twice whatever Maria has. So he has 2 times what, I'm going to just put M, what M has. But we know, Math Marbles, that M has R. R rocks. That's the term for M. So we're going to rewrite this as 2 times R. So that's the expression for Javier, and we're going to put that down. That was our first question. Javier's rocks can be represented with the expression (2R), period. And now let's do Pablo's. So Pablo is Javier's minus 5. But we know that Javier's is 2R. So again, I'm going to take this 2R and I'm going to change it for J. So we're going to take out the J and we're going to put 2R. That's what we're doing here. That's what the substitution is. So we're going to put 2R minus 5. So I hope that part makes sense. Math Marbles, we took this M for Maria and we substituted it by just putting in R. And that's how we got 2R. And we did the same thing for Javier. In this problem, we knew that Javier was the same thing as 2R. So we took out the J and we just put the 2R. So 2R minus 5. And there's our expression for Pablo. Pablo's rocks can be represented as 2R minus 5. Actually, I'm going to put Javier's number of rocks. I'm going to use a number system, and Pablo's number of rocks. So that's what it actually represents. But that's it, Math Marvels. We took our whole plan and we put it into action. So hit pause so you can jot this one down into your notes. And now you've seen how we can substitute expressions so they are consistent throughout the entire context of the problem.